Hello, everybody, and welcome to Dot to Dot. Today, I have something truly amazing to show you. This discovery that was made by Olivier and one of our viewers named Gazbo is truly amazing. It gives us a great deal of information and possibly the origins of the geometry that is interpreted from the Zena Halpern map, and it comes from this picture right here. Now, Olivier has been studying these miniatures that come from the Rochefoucauld Grail. And now this is the image I'm going to be using is a high resolution image that was given authorization by Olivier uh, through the Lancelot Grail project. And this image comes from what's called the Rochefoucauld Grail. And if you look on Google Earth and you can read about what the Rochefoucauld Grail is. And it's basically a story of Lancelot and King Arthur that was commissioned by the Baron, the Duke La Rochefoucauld. And it was commissioned by Guy the Seventh, which is basically around 1315 to 1325. They think that this was created. This Rochefoucauld Grail was created. So it's an amazing thing. Olivier has done some videos. I'll leave a link in the description for him. But this is the the geometry that was developed by uh, Gazbo, and he did this about a year ago, and Olivier just picked up on it recently. And this is the geometry that Olivier drew up according to Gazbo's instructions. And this is a screenshot from his video. Now, I've overlaid this according to what it reveals, which I'll be showing you. And then I also, through this, I overlaid the high resolution image. I also did a scale check to make sure that this image is in proportion, and I did several sizes to make sure that this image is in proportion to the original. So all our geometry will be accurate according to the size and proportion of this picture. So what did Gazbo do? Well, the first thing he did is he took these dots here, and I have indicated the center the best I could, the center of each of these dots in each of the corners. So we have 4 dots that are in these corners here. So the next thing he does is he frames up all the dots like this. And so we have a square frame. Now, this is one thing that I've added because it reveals something at the end that I'll show you, is I took this square and I put in another frame around the picture according to these squares. So we have this frame just like this. So the next thing that was instructed to do was to find the center by connecting the dots, and we get a center here. Now, the next step is to draw a vertical line that passes through the center of this intersection. So we did this. Now, one thing that was came to the attention of Olivier, and he showed me, is that this center actually goes through the very tip of the shoe of the king, King Arthur. So this gives us an indication that maybe these shoes come into play. Now, this shoe right here, Olivier had intuition about it, that it was a pointer of some kind and perhaps a compass pointer. So that keep that in mind, this shoe right here. And it does reveal something very interesting. This is truly an amazing thing. I'm very excited about it. So the next thing Gazbo did is we took diagonal lines down here, and basically we create somewhat of a pentagram. And this comes from the point of the frame intersection with the vertical line to the two dots in the bottom corners. So in analyzing this, the theory is that it is the rest of the geometry comes from, or at least the start of the geometry comes from the gazes of the people in the picture. Now, notice, we have the two. This is the false Guinevere. This is Queen Guinevere. I believe this is King Arthur, and this is a knight. And so we'll start over here with the false Guinevere, and we have to establish somewhat of a rule here and how we're going to draw our lines. Now, most people not like the dots in the corners, but if we're going to draw a line here, the lines usually come from the tangents of a circle. So what I did is I in these lines, I started at the bottom of the tangent of the eye furthest to the right. And notice it comes to the eye of this man here, the knight. And we just go across the page. Now I stopped it right here because that's actually where it reveals something. And we'll show the intersection in a minute. So if we go and continue these gazes, the one thing that we can't do is we did not do it from the bottom of this man, the knight. We encapsulated this pupil right here at the top of his gaze. And you'll see why. Because the real objective here is to find the intersection at this vertical line. The next thing is we go over here and we look at these people here. Now, Olivier had done his gaze from this man right here. However, there is no way you can get it to intersect the vertical line from this man, this gaze right here. So I looked at this further and I see this woman or man or whatever is looking over at this guy right here. And this guy is very interesting. He's very hidden. He's hidden. And it's, he has sort of a sinister look on him. So anyway, I chose him and I went from the bottom of his eye and to the dot. And amazingly, it is exactly in the center of the vertical line. So we have two intersections here that cross this vertical line. Now, the next gaze, we go from the bottom of this gentleman's eye and we go to right here. And then we also, Olivier did this one, is we go from this guy and it ends up at the same point here. So one of the things that is amazing about this picture here is this gentleman right here is giving us, he's really giving his attention to these hands. And these hands develop a number, which is 154. Now this truly is amazing the way it works out. So we take into note that this number 154, and we'll find out what that means in a minute. So we have the gazes set up. We have these two intersection points, and you can probably tell right now what's going to happen. But here's the 154. And the other thing that Olivier did was one of the earliest things that he was looking at this picture was this right here, this picture that he said was it's very basically pareidolia, and it looks like a bird. And one of the commenters on his video early back commented that this bird looked like a puffin. And puffins are only found in North America. So here's a picture of a puffin, and you can see, it has the similarities. But if you look also too, there's a little tick mark coming off of this beak. So what was done is Gazbo took a line off the tip of the beak and went horizontal across the page. And then we had the circle right here. They noticed that there was a circle right here that indicated that there was something circular, and Olivier did a measurement from this right here, and we got a line at 154 degrees. So this is drawn at 154 degrees according to this vertical line. So from here to here is 154 degrees. Now notice that it comes down and hits the tip of this guy's shoe. So we have a shoe indicating the endpoint of this vertical line. Now also we notice that it hits this diagonal right here. This may be an indication. So what we did next is we draw a circle, and we get as a radius, so this is the radius, and we intersect the 154 right here. So this point becomes a point of interest. Now, the next thing we do is we take this diagonal and where it intersects this vertical line, and we go horizontal to the vertical axis. Now, this point becomes a point of interest. So when we go and we look at these shoes here, one of the other things that we noticed is that the other king's shoe right here, if we draw a vertical line up from that and we hit the diagonal that comes from this gentleman right here, we'll get another point right here. So when all this geometry is said and done, we go and we have basically this geometry, and when we put the results of that on there, it ends up being that this point is what is called the set point of Zena Halpern's map. And this up here is cone A. The intersection here is cone C of Nolan's cross. Where this vertical line hits at the shoe is cone B. And it goes straight up to La Hampe, which is on Zena Halpern's map. Now, the other thing that really, with the shoes, is we wanted to know what this checkerboard thing was. And at first we thought it was perhaps a scale, but this is truly amazing. Is the squares weren't really very uniform to do a scale. So if you take, the theory of Occam's razor, basically, and we didn't know why it was vertical checkerboards. But if you go from this shoe right here, these squares, and you count to this pointer right here, there's 20 squares. And if you go from this square to the king's shoe right here, and draw a line, it is 60 squares. And you can see where I'm going because I already have it written here. These are degrees. And if you go here and count these squares to where this shoe tells you where to stop right here with this line in the scarf, if you count these squares, there's 40 squares. Well, the interesting thing is that if you take the measurement and you measure into at the set point, notice that this, I'll get it closer so you can see it goes through 154. So you see it's going through 154 degrees and that the angle is 20 degrees. It's not quite on it here. So there it is, 154 and 20 degrees. So this is telling you right here, this is to the left of the 60 degrees. So what is the 60 degrees? Well, the 60 degrees is the true north, the true heading of Nolan's cross, which is this blue line. So to the left of the 60 degrees, we have a 20-degree angle, and that goes up to what is called the 429 extension. And that is where the square framing hits. And this is part of the Zena Halpern map also, the 429 extension. Now to the right of the 60 degrees, we have a 40-degree angle. And with our line that went horizontal from our geometry over here, from this intersection, if you go 40 degrees from, now it's not quite on cone E, it's about, I think it's 3 feet difference. But if you go right on there, you can see this is a 40-degree angle, and that 40-degree angle goes to the oak entrance, which is another thing that is on the Zena Halpern map. It's the oak. Enter here. This is that point. So when we get all this geometry said and done, we can take away the support here. And I put this on a chalkboard. And let's take the picture off. So when everything is said and done, this is the geometry that you get. So what we have is we have the set point with the 20-degree angle going to the 429. We have Nolan's cross. We have cone E and a 40-degree angle going to the oak entrance. So this is the final geometry that comes out of the Rochefoucauld Grail thing. It's pretty amazing. I don't see how this can be a coincidence, really. The interpretation you can question, but this definitely has all the elements of not only Zena Halpern's map and what we interpreted through through the decoding of Zena Halpern map, which I did in my previous videos. So this is, I'm completely verifying and giving my seal of approval, I guess, on this theory that comes out of the miniature. And it is truly an amazing thing. It gives a validity to Zena Halpern's map, which I can put up really quickly to show you that it complies with that. And if you remember on my previous videos, we have the set point and the scale, which the positioning and the interpretation of Zena Halpern's map does that. So this is truly an amazing thing. Uh, these dimensions of the Rochefoucauld map, or from the dimensions, the distances from this miniature, as we know, these distances right here are equal. They're equal to 1,347 feet, or 1,444 feet, which is the same distance from the North Anchor to Cone E. So I'm just blown away. I never thought that anything would come of these miniatures, but Olivier has proved me wrong, and his persistence with working with these has truly given something that is, I think, very credible. And Gazbo, congratulations! It is truly something. You're the one that actually initiated it and brought it to our attention. So anyway, that's what I have to say. Thank you. Like and subscribe, and I'll talk to you later.